Welcome. This section, section 3.5, is graphing linear inequalities. Now this section, again, it's a graphing section. So again, it's going to relate to 3.2. But it's also talking about inequalities. So an inequality, as a reminder, means you can have less than, greater than, less than equal, or greater than equal. And so that whole alligator mouth thing, if any of you learned it that way, where you have the funny opening symbol. So let's just do some review problems to kind of get your brains going. First off, can you solve this inequality? So as a reminder, that's an inequality symbol. So I want you to go ahead and solve the inequality and see what you get. Okay, so hopefully as you solve through it, let's just work through it. So if I take it, you can solve an inequality just like an equation. So I can move the 5 by subtracting 5 from both sides, and I divide by -3. But one thing happens when you divide by -3. Notice my inequality switched. As a reminder, if you divide or multiply by a negative, the inequality switches directions. So again, if you multiply or divide by a negative, the inequality switches. So that's critical for remembering this. I want you to do this one again. This is similar, but a little bit different. This time the symbol is a little bit different. Go ahead and move stuff around and solve it again. So again, hopefully you said, okay, let's move the 4x over, so subtract 4x. Now we can move the 7, subtract 7, divide by 2. Notice I divided by a positive number, so we didn't switch. Now I'm going to stop for a second, sorry, and notice this right here. What does this mean? What does this mean? Well, hopefully you realize this means I can pick any number that's less than or equal to -3, like -4, -5, but even like -3.0001 is more negative than -3. So we can pick any number that satisfies that requirement. Well, let's go on to one last review concept, and that is how to graph a line. So remember when we graphed, we wanted 3 points. This one is in slope-intercept form, so you could use that to your advantage when we did this previously. So pause the video and go ahead and graph this line. Welcome back. Hopefully, I'm going to start off with points. So this is my graph. Notice I have -4, which means that my y-intercept is 0, -4. And I use this, my slope is 5/3. That means I go over 3. The x changes 3, so 1, 2, 3. And I can go up 5. 1, 2, 3, 4, 5. Or I can go back 3, 1, 2, 3, and down 5. 1, 2, 3, 4, 5. With all of that in mind, we have 3 points. Draw a line through it. Boom, you're done. You just graph the equation. Well, now let's use that for graphing inequalities. Well, when you're graphing inequalities, there are 3 steps. 1, graph the line. So don't worry about the inequality symbol. 2, you're going to use the inequality symbol to determine if your line is dotted or solid. And then 3, you're going to shade one side of the line. The best way to do this is checking a point. Students learn all sorts of other ways, but checking a point is the best way, and I'll explain that a little bit better. So let's do our first example. Y is greater than -2x. So the first thing I want you to do is I want you to graph the line y equals -2x. Pause the video, go ahead and graph that line. Hopefully you realize that is something that has a y-intercept of 0, 0 and a slope of -2. So it goes right through the origin and it has multiple points on it. So this is our line. Now the next question, remember, notice this inequality does not have that line underneath it, which means I cannot be equal. So the y always has to be bigger. For that very reason, we're going to make the line dotted. So we take the same exact line, and we now make it dotted. Okay, so this is where we're at. Now the question is, the third thing was to shade. So now I need to pick a point. So pick any point that is not on the actual line. Again, pick a point not on the line. So I could pick a point over here, like the point 1, 1. I can pick a point down here at negative 2, 2. I can pick the point negative 3, 0. Pick whatever point that you want, and we're going to test it. So to do this, again, I said pick the point 1, 1. If I plug that in, again, I'm going to take that and plug that in my inequality. And so I get 1, and unfortunately it threw that way down there, that's weird, is less than negative 2 times 1, which is 1 is greater than negative 2, which is a very true statement. So for that reason, when we graph our inequality, this place, this side of the line, where our point that we picked gets shaded, and we're going to be happy about it. So we just shaded that side of the line because that's what we saw. All right, let's do another example. Again, I have another thing. So remember the steps, graph the line, is it dotted, check a point. Okay, so graphing the line, we made it an equal sign. You can use intercepts, you can make this in slope intercept form, you can just pick points. It's your choice. So when you graphed it, you should get this line right here. Now the question is it dotted or is it solid? Should be dotted because it is strict, it's less than, there is no equality allowed. So now we just made it dotted. Now let's pick a side. Now before you go any further, we pick a point. The easiest point in the world is the origin point. As long as notice it's not on my line, 0, 0 is always a nice thing to work with. So if you pick 0, 0, plug it in. And again, this thing went weird. 3 times 0 is 0, which is, notice, is 0. And is 0 less than negative 6? Hopefully you're like, well, no. I'd rather have $0 than owe someone $6. So what that actually means is we're not going to shade that area, we're going to shade the opposite side of the line. It's a kind of way of testing and saying, if it's correct, we get to use that area. If it's not correct, we move on to the next region. Okay, so here is a third one. Again, I want you to go ahead and graph this line, then see if it's dotted or solid, and then choose a side. Pause the video and work through that. Okay, so when you graphed it, so again, we graphed the actual equality. Hopefully you got this line that looks like so. Next, is it dotted or is it solid? It's solid because we have that line underneath it, so equality is allowed. So we just have, it just looks the same. Really, dotted takes a little bit more work. Now pick a side. Again, I'm going to use 0, 0, and I'm going to plug that in. So if you didn't do that, pause the video, plug in 0, 0, and see if that inequality holds true. Okay, hopefully when you plugged in, you noticed you got 0 is bigger than negative 4, which is not true, which means we pick the other side of the line and shade that part in. So the critical parts about this are you need to have a nice straight line, you need to shade it, and you also need so the line has to match up with the original equality, and then what it is will determine if it's solid or dotted. Well, let's do one more example. X is less than or equal to 5. So graph it. Is it dotted? And pick a point. Welcome back. So first, what you should have done is graph the line, which is this line right here. Now I went ahead and jumped straight ahead because the nice part is this is a vertical line and I have equality. So it goes right here, and then I can just pick this side because I want any x that's smaller than 5. So that means all the x values this direction. All right, I hope that helps you understand a little bit more about how to work through these inequalities. This is going to come up and be important again in the next chapter, so please don't disregard it, as well as it is honestly going to be on the test. So Make sure you understand how to graph it, and you can make sure that you remember to shade. That's a big thing. People always forget to shade. Shading and the dotted are kind of the critical parts of this. Good luck, and let me know if you have any questions.